Hello YouTube, from this side. So in today's video, we will be discussing about AWS CSI Driver, which we can integrate inside our EKS cluster. So first, uh, we will be understanding what is AWS CSI Driver, and then we can proceed with a small demo which I have created particularly for this topic. So EKS AWS CSI Driver. This is a specific implementation of CSI, which stand for Container Storage Interface, that allows our Kubernetes running on AWS EKS to dynamically provision and attach EBS volume to your containers. So in short, we can understand that suppose we have to allocate some volume to our containers or pods, and if we are using PV and PVC, then we have to manually create the PV so that our PVC can attach or claim that PV, and then that PVC can be used by the deployment or the pod. But there are some use scenarios where we have to dynamically provision EBS volumes, specifically, especially for AWS EKS to store and to use EBS volume, which is used by our application. So you can understand that why it is used dynamically. So first is simplified storage management. Second is dynamic volume provisioning, and it also helps us to improve portability. And as it is an add-on, then it also provides some access and all other stuff to AWS services. So for this video, I am using this GitHub repository and I have mentioned all the steps as well as a manifest file which we will be using inside this demo. So first, as it requires a AWS EKS cluster, which I have already created. So you can see that my Kubernetes cluster is already up and I have two worker nodes here. So first, what we will do, we will be associating our IAM oidc provider with the cluster. And after that, this is the main part where we are creating a IAM service account and we are giving the service account name as this. And we will be installing this thing in our kube system namespace, and we are giving our cluster name as parameter here, and here we are attaching this policy ARN. So this policy is already given by Kubernetes, sorry, it's already given by AWS, so we don't have to create this policy at all. We just have to directly use this policy and mention the ARN. After that, we are approving this procedure to create IAM service account, and after creating the service account, we are creating role and we are giving our role as this name, and everything will be done inside this region. After creating our service account, our role, and our attaching the policy, then we will be using ekctl command to add on to install this add-on, which is AWS EBS CSI Driver. So currently, if I go to my cluster and see add-ons, so currently I don't have that add-on. And if I click on get more add-on and I will search, let me search. Okay, yeah, sorry, Amazon EBS CSI Driver. So this add-on we will be installing in our cluster using this EKSUTL command. And creating the add-on, what we are doing, we are just giving the name of the add-on, and we are passing the cluster name where we want it to be installed. And after that, we are the passing the service account ARN, which we created from this command. After that, we are just forcefully mentioning that it should create automatically. And after that, we will be applying our Kubernetes manifest file. So I have already created three manifest file, which includes storage class, persistent volume claim, and deployment.yaml. So as you can see that we have storage class and PVC, but not PV. So that work will be done by our EBS CSI driver. For this video is meant to be. So first, let us understand what we have written inside our storage class. So in the storage class, I'm mentioning that my provisioner should be ebs.csi.aws.com. So you can copy this from documentation. Nothing is done by custom. Everything is copied from official documentation from AWS as well as Kubernetes. After that, after giving the provisioner, we are mentioning that volume binding mod should be wait for the first consumer so that it will be fetch, or it should take action only when the consumer is ready. After that, we are passing parameters like type, which is GP3 and encrypted row. So as we have various type of type like GP1, GP2, GP3 and all, means this is the storage type of our hard disk. So we are passing GP3 here, and we are mentioning that our volume should be encrypted. So this is the manifest for storage class. And then we have PVC. So in the PVC, this is very similar like we have done in our previous videos, or even if you have implemented it. The only change is we are mentioning our storage class name, which is EBS-SC, which we have taken from here. And we are just mentioning that we would be needing 4 gigabytes of storage whenever our volume is created. So this is the code for PVC. Then we have deployment. So I'm using Nginx application, nothing more fancy. So here you can see that we are just creating single replica, and we are mentioning uh, same thing which we have done already. Only change is like here we are mounting volume, and we are giving the volume name as EBS volume, and this is the mount path of our container. Like this path should be like present in our container, and in the volumes we are passing EBS volume, the same name, and in the persistent volume claim we are mentioning the claim name of our PVC. So EBS dot hyphen claim is the name we have given to persistent volume claim. So the same is getting recalled here, which is EBS hyphen claim. So this would be a very simple and easy demo, so that you can also integrate EBS CSI driver in your cluster, and you don't have to then worry for dynamically provisioning volumes for your applications. And as there there is one another benefit of having this, so that as we will be creating volume, so we will be storing data inside the volumes, and if our application or the pod get deleted, then we have the data within us. So yeah, let's get directly jump into the terminal. So let me open my README. So first and foremost, we have to associate our IAM oidc provider with the cluster. So I will be like copying this, and applying it here. So we have attach or associate our oidc provider within the cluster, and we can see that by going to IAM. Inside IAM, we can go to the identity provider, and here you can see that it is done. After that, after associating the OIDC, now we will be creating IAM role with the necessary permissions for this CSI driver, and we will be setting the trust relationship between IAM role as well as Kubernetes service account, so that my service account, which is residing in my Kubernetes cluster, can have access to IAM AWS services. So I will be directly copying this and pasting the same in the terminal. For your case, you have to change the cluster name according to your needs, and you can customize this as well according to your requirement. And this would be same. So let me also show you this policy. So this policy is already defined inside the policies in IAM, and you don't have to create this policy at all. See, so this policy is not created by me, and you can also see that used as well currently because no one is using this policy. So here, this is how we can utilize this policy. So in the metadata also you can see that this is a IAM policy that allows CSI driver service account to make calls to related services such as EC2 on their behalf. Okay, so now I will be copying this and pasting it here. So service account in Kubernetes will not be created or modified since the we have used hyphen hyphen role only. So we can give around 1 or 2 minutes for this to get set up, and after that we are just left with installing or creating this add-on in our cluster. Okay, so this is done. So what we can say that we have created the service account, we have created the IAM role, and that IAM role is attached with this policy, which is already present inside our AWS cluster, AWS account. So now our service account and our IAM role is binded together. So now we just have to install this add-on. So yes, so this add-on is added here now. And if I go back to my cluster, and in the add-ons you can see a notification like one, and currently I can see that there are three add-ons only. Let me refresh this, and here now you can see that Amazon EBS CSI driver is also installed, and it is in a status of creating. Okay, so we can clear the screen. So meanwhile what we can do, we can bring our Kubernetes manifest file inside our cluster, and we can apply those accordingly. So let me first create a storage class.yaml, save this, and after that we can use pvc.yaml as well. nano pvc.yaml, paste this, save this, and out of it. After this, the deployment.yaml, deployment.yml, paste this, save this, and come out of it. And now let's see the status. Now you can see that status is active, and let us also check if the role is created or not. Uh, so it should be EBS. Yeah. So see here you can see that Amazon EKS underscore EBS underscore CSI underscore driver underscore role is also created, and that we can also check in our README that this is the name we have given. So this is the role name, which we can see that it's created. And if I click on this role and in the permission, here you can see that this policy, which is Amazon EBS CSI driver policy, is attached to it, and the trust relationship is also configured. And here you can see that service account is Cube system because this is the namespace we have mentioned there, and this is the service account. So you can also cross verify that this is the namespace we have given for the service account to get created, and the name of our service account. So yeah, here you can see that our trust relationship is also configured correctly, and the policy is also attached to the role, and our add-on is also installed properly. So now let us apply those Kubernetes manifest files one by one. So first, let us apply our storage class. Apply -f. Storage class is created. Then let's apply the PVC, and after that, let's apply deployment. So yes, our all the manifest file are applied and created. Let us check the pods if the pod is running or not. So our Nginx pod is also running. Let us check kubectl get PVC. So this is the PVC name, if you remember, EBS-claim. Uh, EBS-claim PVC is created, and the status is bound. Bound means that it is mounted or like attached to our storage class. As we have created this PVC, so our storage class has triggered and it has created the PV as well. kubectl get. So here you can see our PV is also created, and it is using storage of 4 gigabytes, which we have mentioned inside our PVC as well. And this is the PVC name. Sorry, this is the name of our PV. We can check the same inside our AWS console as well. So for that, we have to navigate to EC2, then Elastic Block Store in the left panel and click on volumes. So here, the name it is ending with 6LT. Okay, 40 PVCE7. Yeah, this one. So this is the volume created automatically without any manual intervention, just because of our CSI driver and the storage class and the PVC we have mentioned. So this is the volume automatically created for us, and it is in use. You can see in use because our application will be utilizing this volume. And we can also check kubectl first get pods, then we can describe our pod, describe pod, and let us take this name, and here also you can check uh, it should have the volumes. Okay, okay, EBS volume, and it is utilizing that volume. Okay, so now let us do some experiment. So what I'm planning is I'm thinking to get inside our pod, and we will be creating a text file there. And after creating the text file inside the pod, we will be deleting that pod. And as soon as the new pod will up, then we will check that if our data is persisted or not. So first, what we can do, we can go back to the terminal, kubectl get pods. Now let's exec into this pod. Okay, and hyphen hyphen. Let us open in bash, and let me take this path. So I'm creating a test file .txt inside this directory, and let us cat this file if we are able to see the data or not. So yeah, writing text inside pod before deletion. So here you can see that this is the statement I'm passing. Okay, so this is saved. Let us move out of this pod, and now delete this pod. Kubectl delete pod, and the pod name is nginx-ebs-alphanumeric. Let us delete this, and now we should have a new pod running. Kubectl with pods. So yeah, the pod is up and running. Now what we can do, we can print the same thing which we have written in the previous pod. So we just have to change this last ID, which is VWS72, and instead of bin bash, now we can like directly pass cat button, sorry, cat command, and the file path as well. So yeah, it has displayed this message, which is writing text inside pod before deletion, which we have written in the previous pod, which we deleted earlier. So this is how you can implement EBS CSI driver to dynamically provision EBS volume for your application inside AWS EKS cluster. I hope I was able to explain the topic clearly, and I will encourage that you should also try the same from your end. Thank you, and have a nice day.